So which is acting outwards actually. So now same way if I choose another particle. So another particle whose mass is m2. So now which is acting, this is what velocity v, and this one you can see r2 I will take. So can you tell me what is that everybody? So if I go to this, now again r cross v, you go and tell me it is acting outwards or upwards or outwards, everybody. Outwards or inwards, all of you? Yes, please. It is this particle m2 v2 r2. Again it is a what, everybody? It is also acting outwards only, because again it is a what, anti-clockwise or clockwise, everybody? It is anti-clockwise. Clear? So I choose any number of particle. If I choose one more particle whose mass is m3, so at this particle if I take velocity, so this is what, so here also angle is, let me take r3. So r3, so if I go to from here r cross v, tell me everybody, what is that everyone here also? If I take L3 is equals to m3 v3 r3, so here also what is the direction? Direction of angular momentum, everybody, which is also outwards, which is anti-clockwise. Clear? Now, like that, if I go to n number of particles, if it is a purely rotating L number of particles, so what will happen, everybody? Mn, Vn, Rn. So that particle also which is acting what? Outwards or inwards? Everybody?
Outward.
Outwards. So now we want it what? Total angular momentum, because it is total body, not for a particular particle. So total angular momentum means what? We will add it. Net angular momentum. So net angular momentum is equals to L1 is a vector quantity. So L2 plus, L3 plus, and so on. We'll get it what? Ln. Clear, everybody? All of you understanding? Please respond. So now if you substitute it, what will happen, everybody? M1 V1 R1 plus M2 V2 R2 plus M3 V3 R3 plus, and so on. We'll get it what, everybody? Mn Rn Vn. Understanding? So Mn, yeah, Mn Rn Vn. Now we all knows that each mass, each point in a rotating body, somebody's remains constant. Who is remains constant? Everybody? Who is remains constant? Angular velocity. Understand?
Angular.
I can say V1 is equals to R1 omega, because we all knows that V is equals to R omega relation. So next V2 is equals to R2 omega, V3 is equals to R3 omega. Like same way if I go, Vn is equals to Vn omega. Okay, everyone? So I'll replace in place of V, I'll replace with this. So what will happen, everyone? You should speak. M1 R1 omega into R1 plus M2 R2 omega into R2 plus, so on. You can take Mn Rn omega into Rn. Are you clear, everybody? Understanding? Any doubt in this? You can ask. Okay. So now what will happen, brothers, in this? Omega is common, so I will take omega outside. So what is remaining? M1 R1 into R1, R1 square, M2 R2 into R2, R2 square,
R2
so
square.
on. I can write Mn Rn square. So this one is equals to something. We all knows that. So we all knows M1 R1 square plus M2 R2 square plus and so on will equals to something. Anybody? What is the moment of inertia? So that's all it is. So linear momentum, sorry, angular momentum of a purely rotating body is equals to I omega. That's all it is. Okay. So now linear momentum, can you tell me the formula? What is the linear momentum formula? Linear momentum formula, please respond. P is equals to M into V. Understanding, everybody? Now rotational or angular. So what is the rotational? P become what? L. Okay. Now M, what is the alternative? M means what? Here M in linear. In rotational, what is that? Everybody? I. And V means what here? Omega, angular velocity.
Omega.
So that is the angular momentum of a purely rotating body. I omega. That is what you have to remember. Any doubt you can ask me. Yes, understand everybody?
Yes, sir.
Yes. Anything doubt you can ask. Clear everybody?
Yes, sir.
Yes, sir.
So let me take two bodies of masses m, which has been connected with a massless string. So purely it is axis of rotation is passing. So question you can see that. So let me take a mass m. Okay. So another particle also mass m, which has been connected with a massless rod, where axis of rotation is passing, and the length between them is actually total length is L length. Clear everybody? So now axis of rotation, which is actually passing with the omega, angular velocity omega. Now you can see this body, we want to find what is the angular momentum of this body. So what is angular momentum formula? L is equals to I omega, purely rotating body. Purely rotating body, this is about the axis of rotation is passing. Now this body is rotating like this means this velocity is acting like this. Am I right or wrong, everybody? If this body turns like this, then this body will move like this. Am I right? Mr. Rudreswar, understand? All of you?
Yes, sir.
Everybody? So from the axis of rotation, this distance will become L by 2 and this distance also will become what? L by 2. So what is the total momentum? L is equals. Total momentum is what? All of you. This is R actually. So R and this is also R for it. So what is the total linear angular momentum is equals to? Let me take this is M1 and this is M2. So M1 R1 square plus M2 R2 square into angular velocity omega. Do you understand everybody? All of you? So your mass is M1.
Yes, sir.
R1 means what? Everybody. L by 2. L by 2 whole square plus M2. R2 means what? L by 2 whole square into omega. So omega. So which is equals to what? Everybody. M1 L square by 4 plus M2 L square by 4, which is equals to omega. So both masses are same. So I can replace M1 and M2, both are same. So I'll replace M and M. Both masses are equal masses. So M1, I can write it. So now tell me what will happen, everybody? It will become what? L is equals to 2ml by 4 into omega. So 2 ones are 2 twos are. So what is the linear momentum, everybody? ml square omega by ml square omega by 2. That is the momentum, angular momentum of the system, purely rotating body. So, okay, everybody, understand all of you? Clear? So let
Yes,
us
sir.
make this same one with the concepts. Okay, the concept what we studied. So with the help of momentum means we can solve. With the concepts only, let us solve that now. So let us take it now conceptually. So we all take this is first total momentum means this body plus this body. That is what. So total angular momentum is equals to, so L1 plus L2. This one I will take it as a L1. Okay, and this body I will take it as a L2. So now actually R. So if I go with R cross V, this is the velocity and this is the velocity. So now tell me both are, all of you. So anti-clockwise or clockwise? Verify it. Anti-clockwise or clockwise? All of you? Yes, please. Anti-clockwise. Am I right or wrong? So anti-clockwise means it is acting upward or downwards. Angular momentum direction. Upwards or downwards. Check it, circular motion. Like two balls are rotating in circular motion. It will act in a what? Upwards. So MV R perpendicular, which is equals to MV. What is R perpendicular? Everybody. R perpendicular is equals to what? All of you. L by 2. Do you understand it? So which is acting what? Upward direction. Next, at this point, L2 is equals to also. What will happen? MV R perpendicular. So R perpendicular means what? R perpendicular means what, guys? R perpendicular is L by 2. Clear, everyone?
L by
Now, so we all knows that V is equals to what is the formula? R omega. What is R value here? R value, anybody tell me? R value means what? L by 2. Understanding? So I will replace in place of V, I will replace with what, everybody? What I will replace?
L by 2 omega.
L by 2 omega. Do you understanding? So R is actually 1 by 2. So I can replace with that. So I will make it. So what is L1 now? L1 is equals to MV means what? V means L by 2 omega into L by 2. And L2 also what? M into L by 2 omega into L by 2. So what is this value? M L square by 4 omega. This value is also what? ML square by 4 omega. Are you clear, everybody? All of you?
Yeah.
Yes. So now what will happen, everybody? So if I add this total is equals to L1 plus L2, which is equals to ML square by 4 omega plus ML square by 4 omega, which is equals to 2 ML square omega by 4. So 2 ones are 2 twos are. You'll get it what? Everybody, ML square omega by 2. So whatever the way you solve, you'll get the finally same answer. So ML square by 2. So individually you can calculate the total momentum at a time, you can calculate. So the total inertia you can calculate at a time, or you can do it, or you can solve individually. So both the cases you will get the same answer. So that is what you have to remember. By direct method you can solve, by directly find the inertia of the system and you can proceed, you will get the same answer. Or you can solve individually this body and this body. Okay, both you can find L1 and L2 both, and you can start doing it. If you find it also, you'll get the same thing. So that's what you have to remember. So this is the formula for calculating the angular momentum of a purely rotating body. Okay, then next we will study angular momentum of a rolling body. If the body is rolling, then what is angular momentum? That is all we'll discuss in our next class. So I hope you all understand. You can finish it till here. You solve it, everything. Anything doubt you can ask me. So concepts wise, if you want to solve, you can solve this way, or if you want directly solve also, you can solve. Both the cases you will get the same answer. So ML square omega divided by 2 is the linear momentum of a system if the two bodies are revolving. So but problem is here, it is we are making as a two-dimensional page. The page is a two-dimensional, so we are not able to imagine the three-dimensional. Imagine your notebook is rotating, your notebook one side one body, another side another body. If it is moving, one body goes like clockwise, anti-clockwise if you take it. So this body comes like this velocity. So if you are moving from R cross V, I'll send that video, you can watch it. Okay, so just all of you make it. Okay, everybody understanding?